Section 11.6 is on adding and subtracting rational expressions. Recall that to add or subtract fractions with the same denominators, we combine the numerators and put that number over the common denominator. So for example, 2/9 plus 5/9 is the same as 2 plus 5 over 9 or 7/9. The same thing is going to be true for rational expressions. So let's take a look at a couple examples here. Find each sum or difference. So I have 4x over 15 plus 16x over 15. Since I have the same denominator of 15, I just combine my numerators. 4x plus 16x is 20x, and that's over 15. And now if I can simplify that at all, I have to do that. Both 20 and 15 can be divided by 5, so that becomes a 3, and that becomes a 4. So my final answer is 4x over 3. Always simplify if you can. Second example, I have x squared over x plus 3 plus 3x over x plus 3. I have the same denominator of x plus 3, so I just combine my terms on top, and that will become just an x squared plus 3x over x plus 3. And I should probably factor this numerator to see if there's anything I can cancel. And I can indeed take an x out of that, and that leaves me with an x plus 3 on the top and an x plus 3 on the bottom. Since these are multiplied, I can cancel those, and I'm left with just an x. Subtracting can be a little more complicated because we want to make sure that we subtract the entire second numerator. So I have 2x plus 4 over x plus 1 minus x plus 5 over x plus 1. So this is going to be the same as 2x plus 4 minus the entire quantity x plus 5 all over x plus 1. Or, remember, when there's a minus out in front of the parentheses, it's as though you're distributing a -1 to each one of those terms. You want to make sure you subtract the x and subtract the 5. So that's going to be 2x plus 4 minus x minus 5 all over x plus 1. And now combining like terms, 2x minus x is x. 4 minus 5 is -1 over x plus 1. And that's my final answer. And remember, I can't cancel the x's, I can't cancel the 1's because they're not being multiplied. And my last example of this type initially looks like we do not have the same denominator. We have 2x over x minus 1 minus 2x over 1 minus x. And as you know, subtraction is not commutative. X minus 1 is not the same as 1 minus x. But 1 minus x can actually be rewritten as a negative x minus 1. In other words, if I factor a negative out of each one of those terms, it would leave me with an x minus 1 in the parentheses. Then what I can do is, notice I have a subtraction here and I have a minus here. I can actually turn both of those into pluses. So now my problem really looks like 2x over x minus 1 plus 2x over x minus 1. Again, what I did was I took my 1 minus x and I factored a -1 out of each of those terms, and that left me with a -1 and a positive x, which I could write as x minus 1. And since I had a minus here and a minus here, that's subtracting a negative. I can make it a positive, make it the same as adding a positive. Adding across the top, I'll have 4x over x minus 1. And again, you can't cancel the x's because the x on the bottom is having 1 subtracted from it. Now, to add or subtract rational expressions that have unlike denominators, you do need to find a common denominator. To do this, we need to find their least common multiple, also called the LCM. To do that, we're going to factor each expression, and we're going to use each prime factor the greatest number of times it appears in either expression. So let's do a couple examples of finding the LCM. So here we have two monomials, 5x squared y and 75xy cubed. So 5xy can just be written as 5x squared y, 5 times x squared times y. 75 is a 3 and a 25, and 25 is 5 and 5. So 75xy cubed can be written as 3 times 5 squared times the x times the y cubed. Now to find the LCM, I'm going to take each factor the greatest number of times it appears in either expression. And notice my factors in this case are 3's, 5's, x's, and y's. So what I want to do is take the highest power of 3, and that would be this one right here. Looking at my 5's, I want to take the highest power of 5's. Looking at my x's, I want to take my highest power of x's. And looking at my y's, I want to take the highest power of my y's. So my least common multiple is going to be 3 times 5 squared times x squared times y cubed, or 75, because that's what 3 times 25 is, x squared y cubed. That 3 didn't turn out very good. Okay. So factor each term and take each factor the greatest number of times that it appears in either expression. Let's try this with a couple trinomials here. So I have x squared minus 2x minus 8 and x squared plus 4x plus 4. I need to factor each one of those. So two numbers that multiply to negative 8 and add to a negative 2 is x minus 4 and x plus 2. That's what that factors into. And then x squared plus 4x plus 4 factors into x plus 2 and an x plus 2. So my first term factors into an x plus, let me go ahead and write these over here, x minus 4 and x plus 2. Those are my two factors. My second one factors into an x plus 2 squared. So notice I actually only have two distinct factors. One of them is an x minus 4, and one of them is an x minus 2. X minus 4 appears only once. It's only to the power of 1, so I need to keep that. And here's an x minus 2, and here's an x minus 2 squared. I need to keep the bigger one, because that's raised to the second power. There's actually two of those. So in this case, my least common multiple is going to be 1 x minus 4 and 2 x minus 2's. It gets a little more complicated when you have some trinomials that need to be factored. So let's use this to solve a couple addition and subtraction problems. So we need to find each sum or difference. So I have 4 over 5x minus 1 over 10x cubed. So what would my common denominator be? What would my least common multiple be? Well, I kind of do it by looking at it, and let's look at the numbers. So 5 and 10. If my denominators were just 5 and 10, my common denominator would have to include a 10. Now, the first fraction has 1x, the second one has 3 x's, an x cubed, so I have to take the bigger one, so that's going to be an x cubed. So my common denominator is going to be 10x cubed. And fortunately, I've already got that in my second fraction. Now I need to figure out what do I need to multiply my first fraction by to get 10x cubed. Well, the 5 needs to be multiplied by a 2, and the x needs to be multiplied by an x squared. So I'm going to multiply top and bottom by 2x squared. Because what I want to get is the same denominator here. I want my denominator of my first fraction to be a 10x cubed. So now when I do that, I'm going to have an 8x squared over 10x cubed minus 1 over 10x cubed. And now that I have the same denominator, I can just multiply across the top, and I will have 8x squared minus 1 over the common denominator of 10x cubed. So identify what your common denominator should be, and then multiply the fractions by what they need in order to get to that common denominator. My second example is x over x plus 4 plus 6 over x plus 2. So x plus 4 cannot be factored, x plus 2 cannot be factored. So in this case, my common denominator is actually going to be the product of these two. My common denominator is going to be an x plus 4 and an x plus 2. So my first fraction already has the x plus 4, but it needs the x plus 2. So I'll multiply that on top and bottom. Now my second fraction already has the x plus 2, but it needs the x plus 4. So I'll multiply that on top and bottom. So now what I'm going to have is, I'm going to go ahead and distribute here. The x times the x plus 2 is going to give me an x squared plus 2x over my common denominator of x plus 2, x plus 4. And for my second fraction, I'll distribute the 6, and that will give me 6x plus 24 over my common denominator of x plus 2, x plus 4. And now that I have the same denominator, I can just combine like terms across the top, which will give me x squared, and 2x plus 6x is 8x, plus 24, all over x plus 2 and an x plus 4. And I don't think my trinomial on the top can be factored, so that's my final answer right there. And let's take a look at one last example here. Here I have x over 2x plus 10 plus 1 over x squared minus 25. And I'm going to go ahead and factor each of those denominators. 2x plus 10 can be factored into 2 times x plus 5. And x squared minus 25 can be factored into an x plus 5 and an x minus 5. So now I need to figure out what my common denominator is going to be. Well, my first one has a 2, but my second one doesn't, so I need to have a 2. They both have an x plus 5. That's good. And my second one has an x minus 5, but my first one doesn't, so I'm going to need an x minus 5 as well. So my factor of 2 appears only once, I need that. My factor of x plus 5 appears only once in each expression, so I need that once, and then I have an x minus 5 that has to be in there. So now let's figure out what each fraction needs to be multiplied by in order to get that common denominator. So my first one has a 2 and an x plus 5, but it needs an x minus 5, top and bottom. My second fraction has an x plus 5 and an x minus 5, but it needs a 2. So I have to multiply by a 2, top and bottom. So that's going to give me, for my first fraction, let's distribute that x squared minus 5x over 2 times x plus 5x minus 5, plus my second fraction, 2 times 1 is 2, over 2 times x plus 5, x minus 5. And I know you might be looking at this going, ooh, can I cancel those 2's? Don't do that. You want to keep that denominator as it is, because if you cancel those 2's, you're going to end up back where you started, and you don't want to be there. Now, to finish this out, we'll just combine like terms across the top. And actually, there aren't any, so we'll just add those. And put that over my denominator 2 times x plus 5, x minus 5. And my numerator is not factorable, so that's my final answer. Sometimes you'll see people then will go ahead and FOIL the denominator and then multiply by 2 and come up with like a trinomial on the bottom here. I actually kind of like to leave it factored because it says to me that it kind of shows me what my common denominator was, and if I could factor anything on the top, then I would be able to cancel. So to summarize, adding and subtracting rational expressions is a little more complicated than multiplying and dividing. We're going to follow the same rules that we follow for adding and subtracting fractions. So if you have a common denominator, it's real easy. Add your numerators and simplify if necessary. And don't forget the trick about subtracting. If you have to subtract, make sure you're subtracting your entire second denominator or numerator. If we don't have a common denominator, then we need to find one. And to do that, we're going to find the least common multiple. We're going to use each factor the greatest number of times it appears in either expression. And then to add these, we need to figure out what our common denominator is, and then what we have to multiply one or possibly both of the fractions by in order to get that common denominator, and then just add or subtract across the top as necessary.